One of the ways that we can calculate the size of solar panel infrastructure requirements is to use an electrical code. In my case, that would be the Canadian Electrical Code. We can use it to calculate the total demand in kilowatt and use a derating factor to scale any point in time device usage. For instance, 50% derating factor would indicate that at maximum 50% of the devices will be used at any point in time. For example, if we calculate the total demand based on the Canadian Electrical Code to be 30 kilowatt, using a derating factor of 50% would give us 15 kilowatt. We can use that number, the final number, 15 kilowatt, to size the solar panels requirements. We can also incorporate various inefficiency ratios to scale up the solar panel size and also to calculate the battery storage needs for our house. Let's go through an example of calculating the total demand and the load for a house using the electrical code. In my case, that would be the Canadian Electrical Code. So I'm using a GIS system to obtain the area of a house, and that will be used as one of the inputs for calculating the total demand. So for instance, this house has roughly 173 meters squared. Let's assume it's about 175 meters squared. That will be used as one of the inputs to calculate the total demand. Let's also assume that the total area is broken down into two categories, first and second floor, total equaling to 175 meters squared. The system operating voltage is at 240 volts, and we have various loads that are being connected to the main switch of this house. We have the range, so this is the stove, and this is its rating. So we have the stove at 10, electrical dryer 3.4, tankless water heater 3, space heating 10, AC 7, and heat and air are interlocked. So this means that the AC and space heating cannot be used at the same time. We have a EV charger and we have some other fixed loads. The total will be used in this section. So these are actually where all the Canadian Electrical Code rules are applied to each individual load and based on the size of the house. So I'm not going to go into the actual rules, but they're right here. And so we get, based on rules, this is the power coming from that previous tab, and this is the actual sum based on the rule. So the total demand for the house is roughly 26.5 kilowatt. Now we can use the derating factor of 50% to scale this to size the solar panels. So derating this by 50% would give us about 13.3 kilowatt. So we can use this additionally with the efficiency ratios of the solar panel and any losses to size the solar panels. So incorporate the losses, efficiency to size the solar panel, and also size the battery storage system. That way you can get the total size of the solar panel and the battery storage. In addition to using the total demand to calculate the size of solar panel infrastructure system, including the battery energy storage, we can use the total demand to calculate the size of the main breaker for the house. So we'll do just that. In the last tab, using the system operating voltage of 240 volts, the total power connected, and the apparent power based on the power factor of 1. So we'll just assume the total apparent power is the same as the total demand or the real power. The calculated amperage of the main switch is 110 amps. Based on the rules, we have to apply the next size up, which is 200 amps. So the size of our breaker is 200 amps. This is important because if you're planning on having a solar system that connects to the grid, if you're thinking of putting back the energy and getting some credit, then the size of the breaker will be very important because certain utility companies require a certain size of the breaker for you to be connected to the grid. So for instance, if you have a main breaker sized at 100 amps, the utility may ask you to upgrade to 200 based on their criteria. This will force you to pay additional upgrade costs. Any system upgrades that you have to pay to get your size to a certain size main breaker may be costly and may outweigh any savings of the solar panel. So, wrapping this up, we can use the electrical code to size our entire solar panel infrastructure system, including the battery energy storage.